Good morning, everyone. Nice to have you here this morning. We've had a very wonderful, rich conference, and those of you who have been able to hear all the speakers, you know that by this time we are beginning to have a wonderful interdisciplinary understanding of the complex nature of whenever we talk about wanting to improve the conditions of the world, when we want to talk about peace, that it's not such an easy process. And so this morning we have lined up three wonderful speakers, very thoughtful speakers, and I'd like to begin with introducing the first one, who is from the University of Maryland, and I'll tell you how I met him. Last spring, the Rotary Club at College Park, which is where the University of Maryland is, wanted to hear about the Baha'i chair, so they invited me to go to their meeting. And first of all, the humor that this club has is enough to just attract you to want to become a member. It was the most wonderful time, wonderful evening. And of course, this is where I met Bill, our speaker, who is a member, so I was very glad that I came to that Rotary meeting. Professor William Bowerman is Professor of Wildlife Ecology and Toxicology and Chair of the Department of Environmental Sciences and Technology at the University of Maryland. He has been studying bald eagle ecology and effects of environmental pollutants in the Great Lakes region since 1984. He knows everything you want to know about eagles, and this is wonderful because we've been learning more about eagles in Maryland. He has published over 80 peer-reviewed papers and presented over 260 papers at local, national, international meetings. He recently was in China, and he has served as the United States co-chair of the International Joint Commission's Great Lakes Science Advisory Board from 2011 to 2014. He came to the University of Maryland in May of 2011. We're very fortunate to have him. Please welcome Professor Bowerman.
Good morning, and I thank you for coming to this talk. It's quite different than what I normally do. I usually talk about bald eagles. Who can say no to Hoda, right? She was looking for a speaker in my college to talk about something to do with natural resources, and I went, wow, you know, I can show you a case study on water. I mean, I'm a wildlife guy, I'm a toxicologist, I've studied in the Great Lakes for 30 years, but what do I do? Can I show you? Let's talk about an organization I was involved in for 18 years, and as the Great Lakes Science Advisory Board, but I've been involved with the International Joint Commission for 27 years. So let's talk about a really interesting case study, and let's talk about water. And the first thing I want to point out is, look at the slide. What's so unique about Earth? The blue marble. We learned in 1968 when Apollo 8 was going around the moon, we saw this wonderful picture of our blue marble. So what's so unique about Earth? This, water, right? This is the most precious resource on Earth. We like to have wars, we like to have some thought that the most important resource on Earth may be oil, but in reality it's this. You can't live if you don't have this for 3 days. The greatest increase in lifespan for humans occurred in the early 1900s when we chlorinated this. That was the greatest health benefit we've ever done. One simple thing, making water safe to drink, increased our lifespan. But it has to be clean, it has to be uncontaminated, whether it's from chemicals or biological resources or sediments, it has to be good, potable. And 80% of the people on the earth have some problem getting this simple glass of water. I had the amazing opportunity of growing up in one of the places that probably has the least water problems. I grew up on Lake Superior. So I will now launch into talking to you about water. And I will say right at the beginning, this is probably the most difficult talk to prepare that I've ever had, not because of the topic, but because there's so much that you could cover. So how do you get down to an hour with questions? So here's my attempt to try to do that. And hopefully we can have a nice discussion about water and some of the things that I've learned and observed in my life about this precious resource. So as I said, and Hoda said, I started working with eagles. And the Haudenosaunee, the Mohawk Council of Akwesasne, have adopted the eagle as the messenger, and my friend Henry Lickers, who was also on the Great Lakes Science Advisory Board with me for a while, said, if we tell you the tale of Hiawatha, it will take us 2 days. But in essence, you grew up Christian, so let's think about it in your context. So John the Baptist basically shows up, drops a seed into the ground, and pulls up a huge white pine tree fully grown. The 7 civilized tribes have agreed to confederate. And so, under the fully grown white pine, we put the weapons of war. And he places the tree back down, and upon the top of the tree alights the eagle, and the eagle is the messenger. Should anyone go to break the confederation and go after the weapons of war, the eagle will tell everyone about this. So the eagle is the messenger. In many ways, when we're talking about water quality and our effects of water, some of our worst perturbations have occurred post-World War II. The eagle was the messenger, along with peregrine falcons. We first understood the use of agricultural pesticides and the effects they were having on our world and our wildlife because the eagles were showing us. The peregrine falcons were disappearing. If you look, we didn't know what biomagnification was of environmental toxins. And so we didn't know that DDT could go all the way up and go into the food chain. And how did we know this? We had a retired Canadian banker, Charles Broley. I'm still looking for a better photo than that. He was bored, 1950s. He retired, moves to Florida from Saskatchewan. Somebody says, what are you going to do? Well, what can I do? And he said, well, why don't you go ring eagles, band eagles? So he built himself a ladder, rope ladder, and went up. And what he noticed is there were fewer and fewer eagles, and some of the pairs weren't breeding, and so the eagle was the messenger. Something was going on in the environment, which led us to think about eggshells and eggshell thinning, and that was the beginning of seeing wildlife effects. And just 20 minutes from this campus at Patuxent Wildlife Research Center, the field of wildlife toxicology was born, which is one of my fields. And still the eagles are showing some of the effects. When we started cleaning up and banning these compounds, we still saw effects like birds with deformities, which weren't caused by DDT, but really were caused by PCBs and dioxin-like compounds. So the wildlife were our messenger, telling us that there's something bad in the water that's occurring. So that's how I got into water quality. Looking at eagles. I was interested in eagles. Next thing I know, you can't separate working on eagle ecology without looking at contaminants. You end up, in my case, in the International Joint Commission working on these, and that's why I ended up for 25 years looking at water quality. So we're going to talk a little about fresh water and humans. We're going to talk about global climate change and what some of the impacts to water are involved with that. What's the history of the Great Lakes cooperation between the US and Canada as our case study for what is a potential way of looking and working together for water quality and quantity? And then talk a bit about why water quality and quantity are important to peace. So let's talk about freshwater and humans. And here is my beloved Great Lakes from a Landsat photo. On one of the rare days, you can actually see the entire thing without the clouds. And just, again, where did I grow up? Right at this bay. So this is Grand Island National Recreation Area. So my town is called Munising, which means place of the island in Ojibwe. And it's basically the Grand Island with Wood and Williams Islands to the west are the back and the hands of a sleeping giant. And so that's our tale from where we are. Pictured Rocks National Lakeshore, lots of very neat, beautiful places. So what about water? Surface area, 71% of the entire surface of the earth is water. The other 29% is land. And that's just the surface. Except for us, 96.5% of it is salt water. So while we get things from that salt water, different resources, different things to eat, we can't drink it. 3.5% is fresh water, and 69% of all of that is locked up in ice. You know, whether it's in the polar regions or in glaciers, 69% is ice. And an interesting fact I found that I didn't know before, if everything melted, we would raise the water levels up 2.7 kilometers. Okay, so that's a lot. A lot of the surface of the earth would now be even greater into water. So that's something to think about when we're thinking about climate change. So what are our threats to having that safe water? I mean, it's really interesting. I don't know how many of you watch 60 Minutes, but there was a recent 60 Minutes piece about how far people have to travel to get water every day. So just having inadequate access to water. You know, it was primarily women in Africa were traveling, and children, they're traveling like 10 miles twice a day just to get water, bring back to their village for use. And it's not a lot of water. Look at this. You know, for us, that's a 5-gallon bucket. You know, that's not a lot of water. Inadequate sanitation is another major problem. Why do we get sick? Because we may not have water treatment plants. We may not be able to have people that even realize the connection between their waste and disease. So not having adequate sanitation. That's why 80% of the people either don't have enough water they can get or it's contaminated. How many of you have traveled someplace where you're supposed to brush your teeth with the bottled water? I mean, I just came back from one. So if you don't have your Cipro with you, you're in trouble. Another thing is the overuse of groundwater for crops, and we're going to talk about that in just a second with aquaculture. You know, we didn't tap into groundwater as much pre-World War II to the point that we are now. And then we overuse in industrial processes and other processes. We use a lot of surface water, and a lot of times the water going out of whatever process we're using is polluted. And when you think about large-scale areas like China where we're concentrating industry in one single spot, and it may be, say, the ties I'm wearing. Let's have all the silk ties in one spot in China. Concentrates of pollutants in one single area. So water pollution is a major problem with use. And then because water is so scarce, this water is not always in the place you want it to be, right? Either we have too much or too little over most of the earth. Think of South Carolina right now. You know, the Middle East would love to have that water, but it's all in South Carolina, causing $1 billion plus of economic damages. One other thing I forgot to show you. This was one of the coolest things I found on the internet. The representation of the Earth with all of the fresh water. This is what it would look like if all the fresh water that's currently available for our use and the environmental use. That's what it would look like. Just the fresh water. So that's why it's such a precious resource, just a little bit. That's the coolest illustration I could find. So aquifers, here's the Ogallala aquifer. Anybody ever hear that? Yeah. So where do we get most of our wheat? In this bread, we call this the breadbasket of the US, the big plains where the deep soil is, but we're pumping out. The darker blue colors are the areas where we are not recharging the aquifer. We're taking too much water out and it's not recharging enough. So overuse of aquifers is a major problem that we need to address, and it's not just us, it's throughout the world. So we need to take a look at how do we manage those resources. So when you tap them out, they're gone. It's going to take centuries to get that water back. Another thing, deforestation. We never really think about deforestation and water. You know, we always think about the problems in the rainforest and how the areas have to keep slash and burn and you keep doing all of the agricultural use. But deforestation causes major problems. I've worked in Kenya and the Mara River because of the Moi forest reserves being cut over, and this picture is Madagascar. But they decrease the flow of the Mara River, you know, where what do they call it? The eighth wonder of the world, the migration of wildebeest going across the Mara. That water level is down to half because of deforestation upstream. What happens when you deforest? You create higher temperatures on the land, you increase evaporation, you don't recharge your aquifers, you change your whole biodiversity ecosystems, so you get less stream flow going downstream. So deforestation not only impacts the land, it also impacts the water resources. Another thing we have, when we pollute the waters, what happens? Where do those pollutants go? Again, if you watch 60 Minutes, you would be amazed. They've looked in China. Like metal pollution downstream of some of these plants go into root crops, where it's actually above. 40% of the land in China is not actually farmable if you take a look at it from a toxic metal standpoint. However, they don't have any choice. With 1.3 billion people, you have to feed them. In the Great Lakes, we found out this was some of the greatest industrial, uses in the country. Many of those compounds went into the fish, and that's why we have fish consumption advisories. So we have to monitor those. Sometimes we can't eat the fish. How did we know about some of these things? Again, field biologists are out there looking at colonial birds and whether it's gulls and terns ringing them, seeing their populations decline, seeing deformities, things like two snapping turtles. One has a long normal tail, one has nearly hardly any tail. So things that we see in nature sometimes gives us a clue that there are greater problems out there. Another big thing that's come back for us, algae problems. Algal problems due to nitrogen and phosphorus runoff, non-point sources or point sources, is a major impacts to water bodies. It changes the way the water is available to us. We create dead zones. We have anoxia by different types of algae that grow on the bottom of lakes. We create physical habitat impacts where Lake Erie, this is the beginning. You can see this green cloud here. That green cloud eventually filled 2/3 of Lake Erie with up to 18 feet of algal mass in 1 year. And it can be traced back with my science advisory board that I worked on. You can trace it back to spreading manure on frozen ground in the winter. I mean, that's the source. You can move it all the way down the Maumee, and you can see it go into the Great Lakes and then spread. So the physical habitat, you can't drive a boat through this kind of stuff. Another thing, aesthetics. What happens with it when it dies? Well, you get piles of algae along the shorelines that are this deep. Some of these are toxic algae. There's a Lake St. Mary's in Ohio that they closed down. All of the cabins around the lake, you couldn't occupy your cabin because microcystis was too great in the air. It was 6 to 8 times greater than the threat level. So, too many nutrients in that water. You couldn't use your cabin on your lake. And then restrictions of drinking water. 2 summers ago in Toledo, Ohio, you could not drink the water because of algae. They shut it down. What do we usually do to purify water? We boil it. Well, in this case, if you boil it, you increase the toxins. So here's an algal toxin problem. Lake Erie. That, I believe, is a game changer. So when we're looking at managing water and we're looking at what can we do as managers of water, when we look at human-based, we have 3 goals, really. Makes it simple for the public. We need to drink the water, we'd like to swim or bathe in the water, and we'd like to be able to eat the fish from that water source. So if you can clean up the water and have healthy habitats, you're looking at those 3 goals as our water management goals. If we're looking at it from an ecosystem standpoint, because, you know, living here as a human is a lot better when you have some access to natural environments that are healthy and functioning. So you need to have enough water, quality and quantity, where all of the ecosystem is functioning, that we have high biodiversity. There's lots of different types of plants and animals that are native, that are there, and the whole system is functioning and sustainable. So that's what we're looking at. And that, again, takes goals specifically for both the quality of the water and the quantity. Because if you don't have enough water, think of some of the endangered species in the Southwest. They need, or even in the Southeast, we had to have a certain flow rate to maintain their populations because we didn't have enough water going downstream. So the quality and the quantity are both important. So let's talk about climate change. You know, not enough people do. How many of you believe global climate change is a potential problem or one of the most important problems we have? Okay. I'm definitely not in Congress. So what happens? What are we looking at? We're looking at temperature increases, right? Climate change includes, we've all talked about, global warming. Well, that's part of it. Temperature, you can look at all these models, but the world is getting warmer, right? And different areas are going to get warmer faster or slower. The other thing that's happening is water changes, precipitation changes. Areas that used to get water will get less. Some will get lots more. So if we're looking at changes of temperature and we're looking at changes of precipitation, I'm an ecologist, right? What does that mean to me? I'm looking at biomes. Okay, so what are biomes? Those are areas of large scale, geologic areas or geographic areas where we have the same types of things, where it's a deciduous forest or a rangeland or a desert. So the biomes where they are currently, where you know that there's a rainforest, or you know where there's a temperate forest, or you have the grasslands, those things are going to change. If you change temperature and you change water, precipitation, biomes will change. Where you used to have a deciduous forest, you may have a big savanna. You may have a desert. You may end up with a rainforest. But these are going to change. Anytime you change these biomes, what happens? Things go extinct. So, people move. Food sources, water sources change. So, not just our own human activities, but the climate will change the biomes and where we're going. So what are the big effects that we see with climate change? We watch glaciers disappear. You know, you could go up. I went up to Alaska, went to a visitor center, and the visitor center was built where for the next 30 years, this is like the 1990s, you'd be able to see the glacier. Well, the glaciers were seated up around the bend already. Polar ice cap is melting. You see all the big icebergs calving in Antarctica. You see Greenland, you know, disappearing. Well, the green's coming back, but the ice is going away. We have periodic and catastrophic weather events that are more common. Droughts. I was living in South Carolina. The drought was there for 6 years. The ground compacts. When the water comes back, the trees fall over. You know, El Nino, La Nina are more intense and more often. Hurricanes and cyclones are also connected in certain ways, many times not directly to climate change, but are somewhat of a information driven from that phenomena. And also precipitation events. Again, look at that crazy thing that happened in South Carolina with water, rainfall. Some of the greatest snowfall we had in 30 years occurred the last 2 winters in the Great Lakes. So you get these freak events. We call them global weirding. So you have these massive, intense weather events that we haven't had in our recorded history more often. Another thing is sea level rise, something we'll all have to deal with. So this was a great chart. It came from the population project, I think. This just shows lots of different things that occur. And I think it was, what are some of the impacts? And what's really kind of cool about this, if you take a look, so if we increase by 4 degrees, what happens? You go up this side. If it's worse, the impacts of global warming are worse than war, famine, plague, or global nuclear war as our predictions. You know, we're looking at what is the economic value up here in this black. So if we don't invest 1% of our GDP, we could end up having a drop in GDP by 20% just due to climate effects. Think again about South Carolina. It's $1 billion. How many times 20 years ago did we have billion-dollar disasters? We didn't. You know, so if we're taking a look, if we, a 0 to 8 degree change, if we go up by 8 degrees, we end up with larger heat waves, oceans warm and acidify, which is important for habitat, more ice melting, sea levels rise, great species extinctions, the global weirding, extreme weather events, and because the ground compacts, it does increase earthquakes. What our predictions are over the next 100 years, we're looking at environmental refugees, food shortages, collapse of the Amazon ecosystem. Greenland melts, polar bears are gone, and our water supplies are affected. Think about California. It's time to move a lot of the agriculture east because we don't know how long it's going to be until we get the water adequately back there. Islands go underwater. That's already happening. Coral reefs are in trouble, and the rare species are going extinct. They call this the 6th extinction. So climate change is real, and the impacts are real. And of course, here are some things that you can see. water levels in reservoirs dropping due to drought in many areas. The glacial effects, they're going away, they're greater calving, we're seeing declines in the glaciation area. And then sea level rise. What would it look like in the United States with what we're expecting over the next 200 years of sea level change? Well, we're underwater here. Look at the whole eastern seaboard. Think about this map here. Remember that really nice night sky vision of all the bright white lights? Most of them are underwater. The Central Valley of California, where we get most of our food, it's a bay, right? Look at these kinds of effects. We have to plan for these things. Africa, they've taken a look at Africa. There's all kinds of really interesting models out here. That's why it's so hard to figure out what you want to do. So we have areas where agriculture is going to be impacted by current climate change. We're going to change biomes, and what you can't really see well in this light is there's these little circles in different areas. Those are migration paths. It's not habitable anymore. We can't grow enough food. People have to move. What happens when people move? Conflict. Think about the crisis we have going on from Syria. This is going to be food-based, water-based. Okay. And the effects are going to be more in the tropics. And I want you to visualize this later on when we take a look at what's happening in different areas. So the climate, you're talking, why are the tropics so vulnerable? Think of it. Their temperatures really don't change much over a year. They're pretty much the same temperature all year round, right? There hasn't been a lot of movement up and down. We're looking at changing the temperatures and the rainfall. So these species that are currently there, the plants and the animals, evolved for this kind of climate. So this is the greatest biodiversity we have in the tropics and their greatest vulnerability. So, move away from the gloom and doom. Let's think about what's the case study. You know what? If we're talking about peace, we need to have examples. How do we work together? These are big challenges, but how do we work together? And so I'm going to talk a little bit about the history of the US and Canada and how we've worked together with cooperations, especially in the Great Lakes. So, US and Canada have the largest undefended border in the world. I know it's hard to get across to the Canada or come back in, but that's just the border stations. We don't have armed guards. We don't have armies standing along this border. And these are the boundary waters all along the Great Lakes and other areas, all the way from the Atlantic all the way up into the Pacific. And the ultimate wisdom, and remember, we haven't had a war since 1812. So when you look at this, this is a really interesting place on Earth, not a lot of conflict. We, in 1909, came up with the Boundary Waters Treaty, and you realize the treaty is the highest form of law. So we have a treaty, and the treaty manages that boundary water between the US and Canada. With it, we established something new. It was called the International Joint Commission. There are 6 commissioners. 3 are appointed by the President of the US. 3 are appointed by the Prime Minister of Canada. So it's a big deal. We're under the Department of State and Department of Foreign and Trade. One of the things they established is all of the flow levels along the boundary waters would be controlled by the Joint Commission. So we have canals, we have dams, locks and dams, everything that goes between the US and Canada border, the water levels are controlled by international boards between the US and Canada. Another thing, this is the coolest thing they did in the whole water quality, or the Boundary Waters Treaty. We agreed that one side, the citizens of one side would not pollute the waters to the detriment of the citizens on the other side. That entire clause, written in 1909, is extremely unique when you think about it was not until the 1890s when we had water quality brought to the US Supreme Court. So this is visionary. And we also had public involvement. The public had to be involved. Their voices had to be heard in how the water was managed. And we could also permit this commission to do studies to find out about water issues. So here's the Great Lakes. It's huge. 240,000 plus square kilometers, and we drain twice that area. Over almost 500,000 square kilometer area we drain. We have two nations, 8 states, 2 provinces that have a stake in the Great Lakes. So this is really multi-jurisdictional. 40% of the US and Canadian population, and if you think about Canada, 90% of the population of Canada lives within an hour of the Great Lakes. And we have 20% of the entire fresh water in the world in this system. And there's 25,000 kilometers of coastline. So when we talked about managing the water, here at the rapids of the St. Mary's, we have the compensating works. We can hold water back in Lake Superior or let more of it go. We can do the same thing down by Niagara Falls. We can't do anything on managing water levels here other than through the outfall here or the outfall here. And of course, we have the St. Lawrence Seaway that manages trade. Ocean-going ships go all the way up to Duluth, Minnesota to take grain from the Midwest across the world. So this is a very important system. What happened after World War II? We had rapid industrial growth. And the old message was the solution to pollution is dilution. So we used water and we just watered down things. What happened? We had excess nutrient growth because we industrialized farming. We went to artificial fertilizers and pesticides. We had massive algal growth, low oxygen, fish kills. We've been reporting the IJC since 1946, 1950 about the problems in the Great Lakes. We see all the reproductive problems with fish and wildlife in the Great Lakes from the pesticides. By 1969, we say that Lake Erie is dead. You know, the oxygen demand, the entire ecosystem we feel is collapsed. The Cuyahoga River's on fire. You know, this is a river by Cleveland, Ohio, and there's so much oil pollution on the river it catches fire. Things are bad. Look at the tumors on the fish. Okay? So the public, this is the environmental era, the public was an outcry. We got all of our environmental laws in the US, and what did we end up with? In 1972, Pierre Trudeau and Richard Nixon, which blows people away. Richard Nixon is the environmental president. He signed all of the laws because he was worried about Ed Muskie running for president against him. So this water quality agreement is signed between the two nations under the Boundary Waters Treaty. Okay, so it holds treaty law. We're going to control pollution. We're going to find solutions. We're going to measure the cleanup progress. And the standing reference, it's a task for the IJC, is we're going to have a regional office of professionals that work in Windsor, Ontario, and we're going to create 2 different entities, a water quality board and a science advisory board. And they resulted immediately in banning phosphorus in all the detergents along Lake Erie. And we have point source controls, and we get dramatic improvements. We're building water treatment plants. increasing sanitation. So things are getting better. And this is the structure. This is what we have for the case study and what we learn. We need a policy portion. We need a board that deals with policy. How do the government, how do they talk to each other? How do they make agreements? How do they interpret things? How do they determine how to take action? So we have the Great Lakes Water Quality Board, which is the policy side. We have the Great Lakes Science Advisory Board, which is their research side. So when the Water Quality Board says, you know, something smells bad, or we've got all these dead fish rolling up on the shoreline, they go to the science board and say, how do we fix it? What's the problem? And then this regional office was formed in Windsor, so if you're really interested in water quality, quantity, this is a good place to intern. They do take interns or visit. It's in Windsor, Ontario. It's solely focused on Great Lakes issues. It's US and Canadian staff, and they are staffed to support the boards. So when the boards are doing their work, which are all volunteers, we volunteer to do work for the governments and for the people of the Great Lakes. And then our terms of reference, that was an interesting term I never heard before until I started working with the IJC, because it's a diplomatic function. Everything we do has a term of reference. They tell us what we can do. But that terms of reference is they report to the commissioners, those 6 appointed presidential and prime minister appointed commissioners. And this is our really cool new symbol. I mean, the Canadians love it because, of course, Canada is above the US. And because the boundary waters is what formed us, that's our little water symbol. But and of course, Canada is progressive and bilingual, so it's both in US and French. So that's our symbol. So one of the things you have to know is, what are the effects of impaired water quality or quantity? And these are what we call our beneficial use impacts. We looked at these and said, this is what we need to classify. If we're going to clean up something and fix something, here are our 14 beneficial uses which could be impaired at different sites. So things. Can you not eat the fish or the wildlife? That's a biggie. Or does the flavor of those make them impalatable? And can you change that? Think downstream of a pulp and paper plant. You know, it doesn't taste good. Are the wildlife and fish populations healthy? There's no tumors in the fish or deformities. The birds or the animals don't have any deformities or reproductive problems. Benthic invertebrates, the very basis of the food web, are they healthy? You know, the stuff, you know, we look at streams by looking at the benthic invertebrates in the stream body to see if there's a healthy mix, and you can classify how healthy a stream is just by looking in the benthic areas, the sediments. Also, can you not dredge? What do you do with contaminated dredge spoils? You know, if that's there, that's an impairment. Undesirable algae, eutrophication. And can you not drink the water? Either because it's polluted, it's got disease, it tastes bad, or it smells bad. So people don't want to drink it. Beach closings is a biggie, and that's usually E. coli or other problems. Some areas are so polluted there's no surface contact with water on people's skin. Does it cost more for agriculture or industry to use the water? Do we have healthy phytoplankton and zooplankton, again at the bottom of the food chain? And do we have habitat for healthy fish and wildlife? So those are our beneficial use impairments. And what we did is we went through after 1978, when we changed the water quality agreement a little bit, and identified 43 areas of concern. And so each of these areas were the most polluted sites in the Great Lakes and had 2 or more of these beneficial use impairments. And then we started writing plans. We started identifying what the problems were, putting in our action plans, and then getting indicators to know we'd cleaned up the sites. We have been putting in $300, $400, $500 million a year over the last 6 years in the Great Lakes under the Great Lakes Restoration Initiative for our side to clean up. The Canadians don't have quite as much money, but they've been putting a lot of money in theirs. And we've been slowly delisting these sites because we've been taking care of these problems. And in every one of these sites, the one thing I want you to understand, there was always a public advisory council. So citizens could work and get involved locally and say what's important to them and their health of their community. And in the binationals, along the rivers, the green ones, St. Mary's, St. Clair, Detroit, Niagara, and the St. Lawrence, we have binational public advisory councils. So we've gone a long ways in cleaning up the Great Lakes. The other thing that this thing does store when we're talking about science, and this is the only bad graph I've got. This is usually what I have to present. What I want you to take a look at is, here is time, 1981 to 2007. This was a new class of compounds. We've been collecting herring gull eggs, monitoring the water for years and years and years. And when we banned PCBs, you know, that was good. But then what we put out to replace them was polybrominated diphenyl ethers, which are things that are in the foam you're sitting on right now, okay? Lots of different things are used. They're flame retardant, right? So we never knew what this was doing, but what we were seeing in the Great Lakes by looking back at our tissue bank is these concentrations are going up. They're doubling every 2 to 3 years on the Great Lakes. And they found them in some fish, and guess what? We went back to this long-term tissue bank and found these were the concentrations going up. When we got to here, we found them out there, found that doubling rate. The US and Canadian governments got to work and said, we're banning these things. These are toxic, they're bad. We're going to study them, but it's time to act. So they banned them, and guess what? They're decreasing over time. So again, here's the Canadian-US. We use our boards, the science board to investigate, the policy board to get to the governments on both sides and make their recommendations, and we can act to try to clean up the water. These are just small examples. Think of this, 1972. It's been a long time. We have really great, the Baltic Sea and the Chesapeake have the greatest amount of data and case studies for you to look at if you're looking at cleaning up water quality and quantity. So why do these matter and why are they important to peace? And this is going to be very simplistic because I'm a wildlife guy and I was told never to talk about humans, but I have been today. This is population density map in the world, okay? So where do you see the greatest density? About one in 3 people in the world either live in India or live in China. That whole Asian area is extremely dense, lots of people. Here is where current water security is at trouble. So if we're looking at the kind of mauve maroon area, we have physical water scarcity. It's hard to get to the water. The water isn't accessible. The kind of pinkish areas are areas where it's going to be harder to get to the water. And here's economic water scarcity, areas we don't have to develop. How do we get water? How do we pump it out? How do we get it usable? So this shows you some of the areas where water security is very important. Okay, so again, population, water security. And then if you take a look at what probably is one of the largest areas, watersheds in the world, about 50% of the population, countries that border or utilize the Himalaya watershed, represent 50% of the world's population. And like other glacial areas, it continues to contract. And with high density of people, well, again, 1 out of 3 just in India and China, you're looking at increased pollution, decreased sanitation, increased water use. There are problems on the forefront, along with the largest standing army in the world. So there could be conflict. So we have a water crisis. We don't have adequate access to water. We don't have safe drinking water. It's hard to get to a lot of it for 80% of the world. Because we don't have the type of infrastructure in the first world, we don't have adequate sanitation. So much of the water we do get is contaminated with different kinds of bacteria and viruses. We're using groundwater at a pace that outpaces its recharge in the aquifers. So we need to maintain our aquifers. And then we're overusing it. If you think about, and I promise I don't have a big bias against China, but it just happens to be an easy example because we like to buy things at Walmart. So we put all of our industry over there for really cheap goods. And what China did is concentrate their industry along water sources. So the Pearl River 15 years ago had 128 species of fish that were in that river system, and now there's 8. You know, so water use, water pollution, intensive industry, growing food, we like to overuse nitrogen and phosphorus. We get algal problems. All of these are things that are happening because of populations. And we're overusing some of our water resources without planning about regional kinds of things. And there are over 50 regional conflicts that are currently ongoing because of water scarcity. So water is a big deal. So again, we're looking at scarcity of water is going to increase from 8% to 47% by 2030. Most of the people on the earth are water stressed, and that's defined. Think of this, 1.7 cubic meters of water per person per year is water stressed. And most of the world is water stressed. 80% of humans live in areas where water security threats are ongoing, whether it's to the quality, to the quantity, or the potential for conflict. And less than 1% of that whole water source of fresh water is actually usable for humans. We can't move the Great Lakes water to the southwest. Guess what? By treaty, you can't extract water out of our basin. And until you get both governments, 8 governors, and 2 premiers to agree, it's never going to happen. And our current technology for desalination is extremely energy dependent, so it's very difficult. So why is this a context for peace? I think that the Water Quality Agreement, our cooperation between the US, Canada, is a good example that we can use for multi-jurisdictional water management. The World Bank has started a program. Al Duda was the Great Lakes Regional Director for the IJC, went to the World Bank, exported this idea of a policy and a science board to the Danube, to the South China Sea, to the Mekong, to a lot of different areas. So it's important to, I think this is a very good model to use. We've had peaceful cooperation, and I think we should replicate something that works. And when we have problems with population explosions, increased industrial and agricultural use because of that population explosion, and global climate change effects, it's very important that we begin the discussion today on water quality and quantity and use of that. Think of the Colorado River in Mexico. Nothing trickles into Mexico anymore. It doesn't get there. We use it up. We need to manage this fairly and equitably. So I'm going to end with Dr. Seuss. So this was kind of interesting because the context of this was the Ohio Sea Grant actually got these 2 lines taken out of by Dr. Seuss. But I think we should put them back in with the new problems. But You're glumming the pond where the humming fish hum. No more can they hum, for their gills are all gummed. So I'm sending them off, oh, their future is dreary. They'll walk on their fins and get woefully weary, in search of some water that isn't so smeary. I hear things are just as bad up in Lake Erie. And with that, the Lorax said, all that the Lorax left here in this mess was a small pile of rocks with one word, unless. Unless someone like you cares a whole awful lot, nothing is going to get better. It's not. So thank you, Hoda, for compiling all of this amazing group of speakers and for bringing this conference, because peace, those of us in science a lot of times don't think about peace, but it was an honor to be able to come here and talk to you. Yes.
Thank you so much for that informative, very informative presentation and the challenges of water security.